Okay, good morning, everybody, and welcome to the lecture 12, our course. We have still about 7-8 people coming to the class, so I will have to keep stopping to admit them. Anyhow, we will start with flat roofs. It is quite a long lecture, very much compressed, but we will try to see as much as we can so we can have all the material we need for midterm. There was some doubt, so just remember that we said already in previous lectures that the midterm exam will be in 3 parts, right? Online. People keep coming. 3 parts. We already did part 1. It's already completed. Part 2 will have all the envelope from 1 to 6. Today is 5. Tomorrow we will see 6. And next Thursday we will have a bit more support and so on for those lectures. So the midterm part 2 will be on the 23rd, which is next week's Friday, if I calculated okay. It will be on Blackboard online, and the system is the same as we had in part 1. So most of you did it already. And I remember we have 3 students who had problems, so I will take care of that. We'll take care of that also, no problem about it. So please remember it. It is a repetition, but now you have it printed and you'll have it in the handout also and in the video. So as to review a few things, this was one of the questions we had, I think, in previous tests, or I think from the class. We had some problem with the dirt in the facades. And there were like 3 options, like a sealing joints with silicone, leaving joints open, or telling it has no solution. Actually, silicone is a great invention, but it's a product that made our construction wrong, because we do not detail anymore. And this is just a product of too much silicone, right? No solution is not really an option, so there's not good point. Actually, never in life before silicone, which was very much a recent invention, needed silicone, and the facades were much better, right, than now, and much better preserved, even in very old buildings. No solution. Of course, there is no perfect solution, right? We said construction is full of trade-offs, and we have to see the balance of what is advantages and inconveniences. But this is not an option for designers, right? Good design means getting the best of every problem. So nowadays, the best solution, especially in a very polluted place like Seoul, is leaving the joints open, especially with the ventilated, right? If it's not ventilated, you cannot do it. With ventilated cavities or envelopes is the best system. Why? Because buildings have interior space and exterior space. Let people come in. So there is a lot of steam inside, and the building is like our skin. It needs to breathe and have the steam, right, vapor out of the building. If you put silicone in the joints of the stone, that will cause to have all that steam accumulating and putting pressure, and that will eventually saturate the stones. So that's effect 1, it saturates. But besides, the silicone attracts dirt, right? And it has fat. So the fat is absorbed by the stones and the dirt by the silicone. And then when it rains, that dirt is washed to the facade, and we have this result. So we have like 3 effects, right? The steam pressure, Second, so that's a humidity. Second, the dirt. And third, the fat, which is staining, right? So silicon in the beginning looks nice, but in the end makes things much worse. It may have its place, but we have to get used to design without the need of those elements. And you see, this is an exam question. This is another example of too much silicon. This is actually not a bad building. It has nice detailing. This is the Seoul Modern Museum of Contemporary Art next to Gyeongbokgung. But you see the amount of silicon in the joints. This is pretty crazy. This is not a way of building. Really, you'll try silicon to be just a few millimeters, not just the size of the iPhone. And this is probably polycarbonate, right? And you see how the chemical components, those solvents of the silicon, start attacking that polycarbonate. So this is a nice concept of facade, but with a terrible execution and detailing. And the building, which is fairly new, is already half ruined in those areas. This is another case of overuse of silicon, not what's facade. This is the Museum of Education of Seoul, which is in front of a part of the campus of the Cheongdok Library in the center. Nice place, interesting building in brick. And this is obviously a new door, right? And you see the frame is just placed next to the fabric with just 1 or 2 centimeters of silicon, right? And this is not a nice way of doing things. That will eventually break down. It's ugly, it's dirty. And you see what is happening with the rain. Of course, it has no dripper, so the water just washes, and all that dirt, even in the aluminum, is creating a problem. Look back into the details we saw on how windows can be attached to the fabric, to the building. And surely the original doors were done with much more care than here. There was some question about the dripping elements. So some students asked about having modules in the drippers. And of course, it's an example of a wall, right? Just a fence. Actually, this is my house in Madrid. And the fence has just an artificial stone dripper on the top, right? Which is this element. People keep coming. How difficult is it to come on time to class? You don't need to take the bus to come here. Anyhow, so those elements are artificial stone, so they have a fixed size. And in places where the joint is not well done, right, you have the water dripping and the wall getting dirt after the year. So that's not great. But that happens because that piece has this kind of a profile, right? And in the joints, of course, you have to put a mortar. And if you're not careful and the mortar is continuous, you have a breaking point of this dripper. So the water may come in. And this is what happens in this point. Okay. And this is a great building. And you see this very well executed. This is like almost 80, 90 years building. And just a little bit, just 1 centimeter or 2 is enough to have the brick clean. But when you have somewhere in which the water goes through, then the water is washing everything and the brick is ruined. This same building, only here you see the joints were not carefully done, and the water just kept sliding over the bricks. This is here in Korea. So when you have a roof, if we make this section, if you have the timber, you need to have, of course, the tiles, right? You need to have a final tile and some protection in this area, so the water will drip and will not be happening as it happens here. And we saw already, we have examples of not using drippers in our campus. Also, I remember that I told you to think about advantages of different ventilation systems. So I will keep adding those in Blackboard so you have the comments on them, right? And of course, this is just an opinion. This is not exact science. I give you my own comments. We have 2 questions in the chat about the curved panels for the facade we saw before. This is a problem of the design. Yeah, just design. The architect thought it was better. It also helps to have more strength, right? Because polycarbonate is not very strong. So you have a wavy facade, and right, it's not because of the pressure. Okay, good. The question of the Mocha Museum was the damage of the silicon to the panels. Okay, so now we are in the perfect condition, because already 10 minutes, to make our first test. The test is open, and you have the passwords, if I'm not wrong, which sometimes I make it wrong. So please, you have 1 minute to start it. 1 minute to do it. Please hurry up, because a lot of people is still thinking. Okay, still a couple of people missing. We will close it down. Okay. Okay, let's see. Some people coming just bad luck, just in the last minute. Okay, so let's continue with the class. So today we have the 5th part of the envelope systems, and we are going to flat roofs. As happened in many occasions, this is expansion, revision and expansion of what we saw in materials. I had no time to rebuild completely the lecture, but I will give some more material which may be interesting. So the points 1 and 2 we will see fast because it is a repetition. The design process is what interests you, how we design a flat roof. And I stress the design process because with a very few exceptions in assignment for last week, which still quite a few people is missing or are missing, I asked you to figure out some detail. And for a large part of the class, there was like no option but copying whatever instead of working with that logic. And that's not very helpful. So think on the process, on the design, and the examples, the case studies are just as a reference to know how things are done. Just copying things is making us like a human scanners, like a copy machines. And so you learn from that. You need to process what you learn, right? So about material planning, the system and the components, and then how we put them together. Then we will look into detailing, of course, and we'll see like the basic typologies, and then have a checklist we will have in your design process. This is what we did in materials. And case studies, I think we will have some time to see early samples and probably the book examples you will have in the handout. I will add some excerpts in Blackboard as usual, so this may be self-studying. And then about next assignment, next and previous assignments, right? And about the exam, I will comment tomorrow. Okay. Jana just came. Okay, now that we have all the class except one, I will tell for latecomers, since for about 20 minutes, I have to keep stopping. I will have usually the door closed, right? And I will open probably after the test. And then at say once every 15 or 20 minutes, right? So I don't keep stopping depending on the flow of the lecture. So if you're late, you have to wait. Otherwise, really, I have to keep stopping all the time. And this is not way of teaching, because I also lose the thread of what I am saying. And sometimes I forget important things. Then I forgot, so I forgot to say, and then I put in the exam, and you have a trouble with it. So please, from now on, we will do that, okay? So remember, we have different strategies, and the typologies we choose have to do with it. The kind of construction, heavy, light, connected, unified, multi-layer, unified layer, about having massive buildings with large thermal mass, or very light buildings with very small thermal mass. That will change the detailing, of course, and the design character. Also, the opportunity to absorb sunshine and protect from wind, or just the opposite, to give shade and use the natural air to ventilate, right? So one thing we have to be aware is that the roof is the most exposed part. So it has most sunshine, it has the coldest at night, it has the most wind, it has the most rain. So the conditions are much more extreme than in facades, and even than in the basements, which we know have other difficulties, but the environment is really extreme with the roofs. And then specific to the roofs, we need to find specific solutions for heavy rains. Usually cultures with more rain have more sloped roofs, or with the snow, in which we have even more slopes, so you avoid the accumulation of huge amounts of snow in the roof. And also the possibility to shelter from winds. In this case, a combination of architecture and landscape help to filter the wind. If you walk or run or exercise often next to Hangang Park, which is a huge open space, you will realize the effect of a tree's mass when they just filter that strong wind in the river, right? That happens with buildings also. So there is many things we can do just to control or to get most of the climate with the design we do of the roofs as part of the envelope. For history, it is not much mystery. We think a flat roof is a feature of modernity, but actually flat roofs exist since antiquity, right? This is Spain, and this is ancestral constructions, and those flat roofs are just structure with some kind of local clay and volcano sand, which is the south of Sierra Nevada. And New Mexico, which is the other side of the Atlantic, had also ancestral houses, right? There's the Indianos, Pueblo Indiano, in which the roofs are flat. And you can see by the size of the gargoyles that when it rains very heavily. And we have many areas. This is taken from India, from some report in which they use just brick and lime powder mortar. So lime mortar, the plain mortar, to make the roof. And some secret, apparently roofs are executed by women in India, and they have a secret they don't tell men. So I cannot tell you either, but they are quite effective, right? And these are areas in which the rainy season is very rainy. Why don't we use those systems? Well, they need permanent maintenance, right? And this is something we are not used to do now. So these buildings are alive and they keep repaired. In this case of India, it's a bit more definitive, but Pueblo Indiano surely, and for sure that I know in that countries in the southern Spain, they keep maintaining and repairing, they keep painting in white walls and so on. So it's not something which we like. One interesting antecedent, right, of a modern flat roof. What we saw was traditional or ancestral. This is modern, and this is a precedent or antecedent, is a Catalan roof, right? Which is the example of Gaudi. Gaudi used a lot of flat roofs, as you can see here. This is the roof of Casa Milà. And of course, in those cultures, Catalonia is part of the Mediterranean area, and there is a huge tradition of using the roofs because you have a nice view, air, nice weather, and so on. You enjoy it. And this system is very modern in some way. I brought a transversal and longitudinal section. You have, let's erase that. Let's see a little bit in detail because I think is interesting. And this is often an exam question, actually. You have a structural base, right? And of course, that structural base has the possibility to have some water in some points, so they have some kind of a collection of water on the sides, but it's not the point here. You have the real surface of the roof with a slope. In this case, the slope is quite strong. It's about 2 to 4%. And this is just ceramic floor, right? They just, this is some bricks. If you see the transversal section, so this longitudinal transversal section is this one on the top. You will see that over that base layer, we have walls which leave open spaces so the air can flow through. You have ventilation. And then this top floor is supported over those bricks, but they have a small asphalt layer. This is written there, but I'm telling you. So the top can expand and contract without damaging those supports. Right. So look, and then the final thing is that you have always a gap. You see here, you have a gap, which allows for ventilation. So the air comes through, you have ventilation. So all the humidity, water, and even it refreshes, right? In summer, it lets to have it fresh and dry. So the final layer you have in the bottom does not suffer so much. So it has some features which are really modern. And we can mention them. First, to have the independent floating top layer. Second, to have the ventilated cavity. And third, to have this kind of a perimetral gap, which allows for expansion without damaging and allows also for this ventilation, right? So this structural independence, this ventilation, and this perimetral gap are three very basic features or things we use in modern roofs, right? So interesting thing, and interesting to see how Gaudi used that traditional technique to make an architecture which is already starting to be modern. So the filtering of the water, this is why the slope is stronger than usual. So the water will run and will have not time. So they have some drainage points, right? But this is where you have a final collection in that area and some ventilation. So the few drops that may just filter will evaporate and will be retained by this final layer in the bottom. But even if you don't have this final layer, you may have also some waterproofing in that part, depending on how you do it, and depending how long it rains, right? But yes, one of the strategies all the guys do in flat roofs is to saturate a little bit the slope, so the water is less time, and it doesn't have time to filter down. So this is the diagram I bought. You can see it. I will not repeat. And this is the 3 points in different order, but summarized in one graphic, which I wish you do not need to replicate and even not memorize, but the principles, the concept of this roof is quite important, right? Okay. And at home, this is a modern detail. So this is a modern, this is a recent building. So for you at home, you may look around and think what is what and how things are done to adapt this idea to a modern construction. Of course, Le Corbusier was a big proposer, a big defender of that flat roof, and probably Marseille was one of the most beautiful flat roofs. This is Paris, Pompidou Center with water. I add this because water was very trendy in the 1950s and 60s because water provides a nice top, and it's very good to have some kind of thermal thermal regulation because it has so much mass. But water needs maintenance, right? If you have water unattended for just 1 or 2 weeks, you have a full ecosystem of fungi, algae, insects, and frogs. I cannot believe whenever you have water, frogs appear. I don't know where the eggs come from, but you will have frogs, especially in a climate like Korea. So that was the drawback of those roofs. You can do them, it's an option still, but well, in a climate as cold as Korea, we have also the freezing. That's another limitation, right? So you have either freezing and having to deal with it, or too much heat and having that contamination. So, well, that exists, you will see in some books, but you need to have a full circulation system and drainage and filtering and cleaning as you have in a swimming pool. As usual, Norman Foster did some of the most extreme and most beautiful roof gardens in the 70s. This is a building we saw for the full glass curtain wall. And again, when it was published, it was not only that glass only surface, but this kind of having like a really beautiful lawn on the top of the building, which was not usual in the 70s yet. And of course, we can go closer to our time, and Renzo Piano, in a very well-known Academy of Sciences, used this subject, right? And if we go to Seoul, this is a top view of a small neighborhood. You will see that flat roofs are quite popular because you have extra space and you can have your own cultivation garden. So this is a good option in very dense areas. Also, in heavy snows and heavy rain, they need a lot of maintenance. You will have problems, of course. So much for history. Let's go into the process. And as usual, we need to consider materials and the system, they go together. And then once we have those ideas, we have to work on the components. What is happening there? Let's see more chats. One question from I guess there's a question over the Catalan roof. So if you have the base slab from the Catalan roof, you will make small brick walls right, to support that upper layer, and you will make them with the slope you need, right? You will make some transversal ones because you know you need to be sure they will not fall down because of the buckling, and these are like a chest shaped, so they have holes so the air can go through, right? They are very low, very strong, so they don't need to have to be very solid. And then over this layer is where you put that top layer, which you have distance enough to be able to do it with a kind of small vault or a small plate of ceramic or whatever. Now we do it with concrete. Actually, this technique is very used still in all the brick cultures, but yes, so, but there is nothing hollow beneath. So the base is always solid. The top layer is solid. You have just a porous supporting layer in between to let the air move. I don't know if that replies the question. So as we saw in facades, there is some basic layers. We need always to have a structural base, as we saw with the Catalan roof. We need a top protection layer. And then surely we need a waterproofing, and right now insulation, because it is something which we need really, really a lot. Of course, something we cannot avoid is some leveling to give the slope, right, percentage. Sometimes the slope is done tackling the base, so sometimes the base is already sloped, so you don't need that layer. And depending on the insulation we use, we need a vapor barrier. And then depending on the materials we use and the system we use, we need separation layers so things do not touch. So we had a question today, we will comment later. Some waterproof materials and insulation materials are not compatible, so you need a separation layer. And sometimes you want to have a float in the top and you need another separation layer, which also protects the waterproofing. But the basic layers are those three. So you can avoid the protection sometimes because the waterproof is self-protected, and you may avoid the vapor barrier if you have another solution for it. And of course, as we said with the facade, with the vertical facade, we can change the position. Of course, we have more limitations because you have to deal with water and with gravity, but this is the basic materials. This is the summary from the book. So you will have waterproofing, insulation, and protection, and they give you some graphics, which it is okay. This is very much the Swiss precision, but you will try to have your graphics to be very, very distinct. So to see easy to distinguish. And I find them very similar, and they're not always easy to see the difference. And sometimes if you don't see them together, you will have difficulty knowing what is what, right? It is okay. So it is a very good and famous book, and very systematic. Again, I think in your graphics you have to find a way to be more clear to avoid confusion. As we had with the windows, you have a full description of each of the layers. I will not go into detail, you can read, and even the choices of materials you have, the thicknesses, will comment over the details, right? But it's a very nice summary you can read, and you will have also the excerpt or the book if you have it. Important, the separation layers, as we said. Very often we need the materials to move, to slide over each other and to not touch. Important thing also is the ventilation cavity whenever you can, because that will help regulating heat and absorbing that humidity. What we said in the beginning about the silicon ceiling and the building needing to breathe, that taking the steam away is very good for the interior environment and to avoid the humidity accumulating. One point is the impact sound insulation. If we have flat roofs, people can go on the top, but we can also have hair, right? Like a strong meteorological impacts, things falling, and this will be a lot of noise to the lower floors. So you have to make sure that sound will not be over what is admitted. There is famous a case of some auditorium who has a glass roof or glass or very nice light roof, which in rainy days are impossible to use, impossible to hear. In some cases, over that space, over that glass or noisy roof, what they have is a net. They can have permanent or just deploy if it is just rolled. So when the water falls, it's sprayed and doesn't make that big noise. So it's like reduce the speed and so on. Very similar to what we saw in the strategies for the plinth, is done to filter the noise in the water. I think somewhere, some Vienna Philharmonic or some places that I heard they had. I have not been in Vienna, so I cannot say. But I can tell you the noise on the flat roofs is sometimes very, very annoying. And finally, leveling layers, we said, you have to go at least to 1.5. Sometimes you may go to 1%, but 1% you may have ponds because it's very difficult to make. So 1.5 to 3, 4%. Over 3%, you will feel it very steepy, right? But safer. So you have to have this leveling layer, but there are exceptions, right? We'll see a few techniques which may have 0% slope, just gets floated and slowly evacuated. But in general, you have to work with this. And of course, as we said, if you make the slab already with a slope, you don't need to add this layer. We need to have a lot of idea of waterproofing, insulation, and fireproofing. Well, it was the lecture with some materials. I will not repeat all because we don't have time, and this is why we have materials before. We are repeating and reviewing already enough, I think. But waterproofing insulation is basic. So you have the link to the handout. I think it works. If it doesn't work, let me know. And I will comment just a few things. That we have like 3 main families of waterproofing materials, right? Bitumens, which are mainly from oil, mostly from oil. Polymer sheets, of which PVC, good quality PVC, is quite safe. It's not very ecological, but can last for a long time. Good quality. Bad quality doesn't last much. And polymer painting, which is the most used in Korea, right? All they have their advantages or their conveniences. That's discussed in the lecture. You will have the different qualities of painting. So it's from very cheap, in all 3 categories, you have a very cheap, very unreliable materials, and more reliable but more expensive or more complicated to apply. So you will have to consider what is best in each case. One advantage of polymer painting is that it is continuous material, so you don't need to detail the joints. You just paint, and you have a layer of paint, waterproofing, and that's all, right? One important point here is the incompatibilities of bitumens with polymers. This is what we saw, the problem we saw in the MOCA, the modern admixtion, within the silicone, which is also oil-based fat solvent with a polycarbonate, which is a polymer, and probably that fat, that oil is degrading the polycarbonate. Bitumens are pure oil processed, right? They have many ways of being processed, but that also may interact with polymeric insulations as a polystyrene, which is the maybe most used in Korea, the famous isopink, or the styrofoam, right? So in that case, you might want to use a different insulation, like probably fiberglass or so on, or to have a separation layer so they don't touch. You will minimize that problem. There is a material which is very popular in Korea. This is the heat reflecting aluminum foil. This is based on radiation. It has been already, well, over 20, 30 years in the market. but yet we are not very used to manage the radiation. All the calculation systems we use is for transmission, right, and convention. So the radiating heat conditioning is, or at least that I know, that probably we should ask Professor Yi Guangho because he is very expert on that. It's not so well tested. So it has advantage of being very thin and very light, but you need to use it in an enclosed air cavity to be efficient, to be effective. It is the same when you have those kind of foil blankets, which really are effective. You are sitting, right, and you put a blanket on top of you, and you are really creating an enclosed cavity, so the whole heat remains inside and you get warm. So you create a cavity yourself. In buildings, you need to have a closed cavity where you put this insulation, and then it will work. Right? If it is open cavity, probably will not work. And that's very difficult. You have to test how the building is working. Other material which is interesting is the aerogel. Very expensive. It's a jelly actually. And usually it is used impregnating felt. And commercially you can buy from 3 to 10 millimeters thick, because it is like probably 5 times as effective as any other material. And you can have it transparent, right? So you can use it in the igloo and you improve a huge lot the thermal performance, but without reducing the light. But again, this is very expensive, and you will use it mostly in places which are difficult, in thermal breaches or not in large surfaces. Well, I was saying the opposite, right? So the first decision for the system is to be flat or sloped. Obvious, right? And in each case, very difficult decision actually is to evacuate the rainwater from the exterior or from the interior in both cases. They both have advantages and drawbacks, and also with the evacuation systems, right? An exterior is very safe, it's easy, but it's ugly, and it can damage the facade, right? Because you have splashes and so on. Interior is a bit more dangerous because you may have more leaks. It's more difficult to maintain. It is noisy inside. You need to insulate because you're getting the cold inside. But the good point is that it's easier facade, right? So you have not facade interruption, and you do not need to have those solid pipes out, inside. And of course, it also takes space inside. So you have to plan for those pipes taking some uncomfortable space, and you have the pipe plus the insulation for the heat and the noise. They will be quite thick. Let's close it. Then you can think on how you put the insulation. Traditionally, we put the waterproofing at the top, but with the new polymeric waterproof insulations, we had inverted roof, and this is printed because of that, because the insulation is on the top, and then it can be non-ventilated or fully ventilated, right? And ventilated in a way that you use the space. The same happens in sloped and flat roofs. Only in sloped roofs, if you have this ventilation, you will need some kind of air exit for it to work. The drainage system, this is from your Sombe of already 7 years ago, and they had a small catalog on how you can use that evacuation with the different advantages and so on. And interesting, this is for the World Cup Stadium, which had a very complicated system. Actually, it's like a combination of small sloped roofs, which collect the water into a pipe. And then the problem of this case was the pipes. So the pipes on the exterior don't have place to go. And this is a very nice stadium, and well designed, well engineered, but this detail LYT. Let's see, LYT, where we have LYT. Good question. I should check. This lightweight dimension. I will check. Yeah, I'm not sure. I will check. Thank you for asking. Because this is out of context. But here the question is the difficulty we have with those pipes in the design, right? Then, of course, you can have a non-usable, usable, and green, and that will have different detailing and different problems. This is the best, probably most complex, and this is the easiest, cheapest to detail and to maintain. For green roofs, we can use them in sloped roofs. Of course, we need a technique in which we have the support layer not running down. Then the choices are limited. This is in Pukansan Park, some of the information or support cabins. But in general, the system, the secret of the point is to have a filtering layer as we had in the basement walls with a drainage layer. Actually, this is the same material we use in vertical for this drainage, right? So in a very thin layer, you may have a clear separation between the sand and the insulation, and you don't have accumulation of water. And usually, in general, they are inverted, as you see, because we give more protection to the waterproofing, and it works very well as in the layering system. There's another case from a real photo with a minimum layer for grass. Actually, I studied that for grass, you need at least 15 centimeters of layer, but I see that today with some kind of a mix of sand and polymers, you can go to 5 centimeters for grass, right? So you make it lighter and so on. But eventually you have this drainage layer. See the separation felt, so these polymers not touch each other, expanded polystyrene, and then protected separation layer again, this is what we said, and a double layer of, actually triple layer of bituminous finishing. With, of course, one extension in the parapet, you will put always 20, 30 centimeters, as we did in the plinth, right? It's the same case, to avoid that humidity, that splash to damage the walls. You will see plenty of those. This is, I think, Lotte department in Chonlianli. This was taken a little after the building was finished, when everything was nice and clean. And you can see you may have nice full gardens in the roofs. And in some places, like from a few years ago, cities like Paris demand every new building to have a garden roof. If they're usable, you have to preview this kind of pavement. Of course, Ville-Savoie was the example of a nice try, but a real disaster in terms of performance and detailing, because they had no experience. But it helps us to see the difference between the usable and the roofs which are only there for maintenance. So the components, because we're very slow, the typologies, the warm deck is the usual, the traditional. So we have the layers as we said in the first slide. Cool deck is interesting because this is the same warm deck, but the protection is separated so the air can go through. So that has a less thermal stress in the waterproof. It's better protected, so it gives you much more durability of the waterproofing, and also helps to have that layer dry. And finally, the inverted, we said, in which the insulation is in top, so the insulation will get wet, and the water will go through. But apparently, experimentally, we found out that it doesn't affect much the insulation power, so it doesn't cool so much the lower layer. Of course, it has a very good protection. You can put the insulation right after you waterproof, so the chances of damage of that layer during construction will be very, very little, very reduced. Cool deck is very used, and of course, you have variations. You can mix different systems, right? So let's go into the detailing, and this is the basic detail we always see. just again from the book. And this is the symbology used for from the book. You will see that we have always a problem with insulation. So you have very well insulated wall, very well insulated roof. We have additional insulation as much as we can, but then there is always a thermal breach which will affect the building. This was okay in 2008, but it's not okay in 2025. So we have to improve our detailing. Same happens with the water coming out. So this pipe will make noise and this is the exterior, right? So you will have heat, so you need to insulate so you don't have that cold water creating condensation problems in those walls and giving noise. So insulation is a weak point, but apart from it, you see the layers. I don't need to tell them. They are written from top to bottom, but see that in a very basic roof, we have up to 70 centimeters of thickness, right? That's the height of your desk. So when you draw a section, even in concept drawing, you will need to have a much thicker slab in the roof than in almost any other floor, right? And that way of drawing will demonstrate you are really much more aware of what you are drawing. There are interesting points. So see how you have a top element without joints, which covers all those layers. You see the tripper, it's not drawn, but it's not very clear, but you see that the water always helps to be taken away from the wall. See again the extension of the waterproofing. In this case, about 15, but in most codes it's 20 to 30 centimeters, but we have to go up from the finishing layer of the splashes. And you will need always to have some continuity of the, let's put a waterproof in this. So you will need like a duplicate waterproof on those connection points and make sure it is continuous until the water slides. So the water will not accumulate and will go out always, right? See always also this gap we have between the pipe and the walls. It's not offering insulation, but also because things need to move independently, so the pipe will not crack. Well, this is important points. And usually it's the 3 points you have to detail always. And you will have plenty of variations depending on the kind of roof you are doing. This is very ugly, but still is summarizing what you need, right? First, the top element, very important, and the dripper. You may have a continuity on the exterior, so the water will be mostly conducted to the interior, but you may have also two side elements. You will see also often. But many people do not like this line on the top, other people like them, and it's a design question. Then the vertical extension, something which is not very clear here, but you will have always one layer of waterproofing and then a second layer on top of it, right? And you will always overlap, duplicate, and makes this bending soft. I exaggerated because if you bend very strongly, many of the insulation materials may crack and you will have a weak point. This bending also helps to have some flexibility when it expands or contracts. So they have some possibility of the movement there is not creating tension on that element. Something which we learned from Gaudi before, or Catalan, is that expansion joint. There is a huge amount of sunshine and also of cold, right, coming here. So this top slab will expand and contract a lot. So you need to have the expansion layer. Otherwise, you may have too much tension here and that top may end cracking. This is very common problem we have. If not, if this is too strong, it doesn't crack, this element will just bump because it cannot resist the pressure or will destroy the drainage points. And as we said, we need freedom of movement, some gap to really for constructing, and then some insulation of the pipe there. And well, this is what we had before, right? You can check by yourselves how those things are done. And well, one more example from the book. This is very unusual because it does not have really a top layer. See the pain they have to have continuity of insulation. This is by using those connections. And then when you have glass, you cannot use the strategy. So you have this extension of insulation. But as we said in previous lectures, this was okay in 2008. Now you might need to go with this line much farther, and maybe you lose the advantage of having this mass inside the building. So this is a detail we have to rework nowadays. Again, very thin roof, but you will go almost to the 70 centimeters again. And this border is solved by using paint, right? Coating a kind of mortar, waterproof mortar. So the whole water will go inside to the roof, but in the exterior you will see almost nothing. So an example of a Basel in which the insulation again is interestingly done with continuity, but again we have this thermal bridge. Intelligent point, well, you see the two drippers, right? Is when you have handrails, you will try to put them in a vertical connection so the water will have less opportunity to filter to the inside. And you have a protection from the dripper and the gravity working in your favor. Other elements, I let you to see how they are done because they're quite interesting, right? Like the extension, the duplication of the waterproofing, and so on. Another case from the book is an interesting point in which you have a garden and a terrace, right, next to it. So the water just goes from one layer to the other, right, at some point. And they will have the drainage, of course. But in the case you have overflowing, you will have an emergency gargle, water exit, right? So this in the case the normal drainage doesn't work. Again, see the difficulty to have that insulation continuity. In this case, it works better because this is already exterior, so there's not total break of that barrier. And see again those details of well, this is from the top, so we have another finishing of insulation and waterproof on the top, and also in the bottom, right? This extension, of course, this is someplace it can go on, so they will not go very tall upwards, but actually the water is running from lower, so you have probably in the end 20 centimeters minimum expansion there. And this finally will be commented, right? Another case with a terrace, again, this is interesting because we see we have a thinner element that's not garden here. See the way of having the water filtered in a layer and taken to a gutter, to a drainage, a trench in the end. We have a lot of questions there. Yes, so sorry, I didn't see. Okay, for the question 10 minutes ago, I have to go later to see it. But yes, most garden roofs, it's not necessary, but that inverted layer, you will have the insulation always having additional protection to the waterproof, right? Because those roof gardens have a lot of weight, and that waterproofing will let it work much better. It's not anything in inverted roofs. You need to have a waterproof, really waterproof insulation. You cannot use anything. And I have one like message. Oh no, that's okay. So I hope it replaced. Then the left not okay. I don't remember anymore. Sorry, I didn't see it on time. But I will go back into the video and see what it's about. Okay. So interesting to have this kind of trench at the end, and very intelligent to have this thin cornice. You see always a dripper. To have one folded stainless steel or aluminum plate at the end, right? See always how you avoid to have anything perforating those layers. You always put handrails in other places which are solid. So instead of having a very thick front of the terraces, you have very thin vision of those terraces. If we go back to the slide, right? So you may like it or not, but to have this very thin front instead of very thick terrace, you use this kind of detailing. And this is not standard. This is something that the architect is working hard. And this is what is really interesting and engaging of this detailing. Again, we have problems with the insulation. So the thermal bridge is there. And we have to, probably this was what we were saying before. So the problem is the thermal bridge. So there's a point in which in a few years ago, we had enough insulation with this extension, because concrete is also insulating. So if you have 1 meter of concrete, then you have an acceptable insulation. But now with the zero energy buildings, we need to have maybe 3-4 meters. And then the full room is with insulation, and you don't have the advantages of the thermal mass of the concrete anymore. Okay. Okay, and this is expanded. This is how it is in the handout. And then another case, which is interesting because this is a ventilated, so it is cold deck, but the waterproof is on the top, and you have a ventilation inside in a timber building. This allows to have perfect continuity of insulation. That's great. And this is a timber construction, which also helps. But having this ventilated doesn't make the roof thinner, but we'll have to have very, very thin in that end. And you see the pain or the work to have those endpoints with a metal protection, which will support the 2 layers of waterproofing, right, overlapping at some point, and one element which gives you the tripper, right, in which the joints are always hidden. And the entrance of air, always you put some kind of a net, so the insects and birds cannot come in. Birds are amazing. They can enter anywhere. They get into that layer, and they may have a life there. So you may have families of birds, owls, and pigeons living there. But if the hole is very small, they might not find the exit, and they might die there. And you have a noise for some time, and then you will smell for some more time. Okay, one more case, we have to go fast. This is very similar, but this is a more modern construction, right? Well, not modern, it's not timber, have all the layers. But again, interesting to see this, this is an aluminum element possibly, to have this tripper, to have this protection in the ventilation area, this net we said before. You see how they are using also double layer of waterproofing, and finally, just a small protection weight that gives some shade and also avoids the wind to damage it. One more case, another case in which is a difficulty to put the handrails in some way. So they don't explain how they fix them. Actually, it's crossing the full barrier. But again, you have some continuity of insulation. The cutting is minimum, so it's quite interesting in case in which the insulation is totally outside. And you'll see again that this is really not a standard detail, but you will recognize many of the things we saw before in general cases for roof, right? That replicating the layers, having a soft angled bend, and then going up always at least 20 centimeters from the base. Again, taking materials from your zombie, this is the detail they figured out was in the KT Tower in Hammond. This is deduced because we didn't have access to the detail. If you have it, you can share. But this is basically the general detail we saw. And again, here the insulation goes over the waterproofing because it's quite practical for the garden construction. At home, you can think the different advantages and inconveniences of those decks. And well, you see a construction of one office building. We saw this in materials. So this is paint, but even in paint, you have to make multi-layer. And this is the reflective insulation, which I wonder will be effective in a ventilated cavity. So I would question how well does it work. This is the paint done. The inconvenience of paint, you need to have a very dry, clean surface. And in Seoul, you have a full of dust in just a few minutes, right? So then while it dries, must be also clean. So you have to see the meteorological prevision to make sure it will not rain. We have no problems. Then you have a full structure to allow for all systems of electricity, communication, water supply, and so on to be displayed. And you have a space enough to work inside. And you have open joint, so the water can just fall in. And if it needs to evaporate, it's ventilating, so the water evaporates. We do not put silicone there at all. Of course, the slabs are just put on top of the steel. You could have some nice intermediate layer to have not the stone and the metal touching together, but okay, this is how they did it. And this is just the visit of the students and the roof finish. So you will know now that under this space is about 40, 50 centimeters of a gap with plenty of installations. And that allows to have space for those plants, right? And this is the roof garden we saw before, which works in a different way. So in case this is Madrid, so actually this is a pool. If you use water, you need to have a real pool. Right? And then you will have the timber always with some margin, so it can expand and contract without bumping, without having problems for expansion. Actually, it's cool to have a swimming pool in the top of a city. This is really expensive apartments. I was able to, it's not my construction, but I was able to see the finished building because one of my friends was doing the construction supervision. Here's what I was saying. You always put a small gap to make sure the timber has space to expand. Of course, you let the water go through. One more example. In this case, you see the slope is done by the structure itself, right? And this case is inverted. So you have the main waterproofing just under the insulation, which works great. And again, you see the complication they are taking to make sure there's not any thermal breach. And this is okay in the section, but then you will have to figure out how to fix those windows to the solid structure because you cannot fix them to the insulation, right? See again, the expansion joints. So that means they will have some kind of a steel connection at some point so elements do not fall down and are well supported. One thing important is the flooding check. This is asphalt, of course. In this case, the overlap is too small, so you have to find a way to make a detail in which you have a safety enough. Actually, this is a roof which gave problems because they had only just 5 centimeters of overlap there. Usually you put 48 hours water, just a little bit, a few millimeters, because it is not thought to have pressure. And you will check for the leaks and you will repair. The same with PVC. This is a case of roof with a slope. So this is the exception we saw, that exception of 0% slope. This is a PVC. This is the same as a swimming pool. This is the same material, not the most expensive, but some swimming pools use this material, or tanks also. If the PVC is of good quality and is well done, may last for a long time. And here you have to do also the same kind of waterproofing test. I brought more slides because it's interesting. This is inverted and it's composite of filtering tiles, right, with insulation. It's a composite of tile and insulation. So the water goes through between the waterproofing and goes back to the drainage layer. You leave always some kind of gap, of course, and the rest of the details I don't need to repeat. So just try to identify elements as we see them. That's how it is done. You avoid the corners by just filling with gravel those areas. Right, you see the process of doing it. And the finished element, you see always you have this margin of 20 centimeters in the borders. At home, you have a detail to see, and with this, we are almost done. I will just go fast into the checklist. Just read it because it is just a list, very easy to see, but I will insist that you need to draw the levels, right? So if you have a square element, you may have a trench in the center, so you will give some slope in each area. It's like an inverted roof, right? And usually you will have this kind of inverted pyramid. If we make the section, we will see those sides and the front, right? So the section will be like this, right? Taller on the borders and lower in the center. So if you do that, you have to, let's go back. Usually every 100 square meters is just to give a reference, is to make sure you don't have too much water. It's 10 by 10 is very nice reference. This is quite well done, right? You don't need to have it in the center. It depends on what opportunity you have to keep those pipes down. This is the continuity with the interior. In one roof, at least 2 drainage points. That's important because if one clogs, you have the other. And of course, this is just to pre-dimension to work. If you have a larger squares, you will need thicker pipes, right? And you will have heavier roof because you will need to get much more height. But it will be more simple. If you have smaller areas, you have more safety, but you will have many more pipes and many more risks of having humidity. This is, I brought this because this has not logic in terms of geometry. This is what I was telling. If the squares are very big, you will have much higher leveling, so you will have much heavier elements. So you need protection, of course. Make sure the water goes through, does not get a pond around. This is what he said of the expansions. See the cracks around. This is our library. And this is why you always need expansions every few meters and in the borders always. This is the summary. We don't need to repeat. It would be nice you do at home. And you will see always those problems which happen with the poorly done details, right? So we will have not time to go to the case studies, but from Le Corbusier I brought just a few photos which are interesting to see the connections of visitable, not visitable, and the restoration, the trenches they did just in the borders to collect the water. So it was original. So initially it was quite modern with direct exit to the exterior. Right, the problem of the exits. So some small details in the restoration were quite well done. And probably Farnsworth House, we have just 1 minute to see it. You will have the full handout. It is not something to imitate, but as many things on the 1940s, 50s, it was the ability of those architects to really figure out details which were not standard. You have always interesting definition of materials, much more distinct than the one in the Plaza's book. Nice building, nice details. You have a section, you have a general view with the position of the details. This is a nice way to arrange the drawings. And then you have each of the details. Look how Ms. van der Rohe used solid steel to make fixed windows. This is the kind of exercise I tried you to do, but we will comment tomorrow. I added this because this is one of the examples of how you can deal with only steel and standard materials to make a window. In this case, is kind of a modern classical detail, right? Also, the connection to the structure. So thermally, it's a disaster that makes us for a nice building. Look, the interest from insulating, but again, at this stage, we have thermal breaches almost everywhere. So thermal is not great. Interesting is the way of putting the details, right, with these kind of gaps. So the elements can expand and contract. So you have a continuous floor. Well, actually this is aluminum door, but again, it's not a detail you can see. And interesting this detail in which you have a sliding element in which, because the building is very light, the roof may have some kind of a deflection. So you have a few millimeters for that door to move without getting totally stuck, right? Because of the door, that tetanus element, and then the top and the bottom with the drainage layer, which is a nice detail. I laid it here for you to see. It's quite nice in English, actually. And of course, the examples you will see yourselves. And since we are finishing, let's, the exercise we will comment tomorrow. Just go to the final test and you have 2 minutes to do it. And that's all for today. After the test, you can log out and see you tomorrow with more proofs and more questions if you have them. Okay, please, those who didn't start now, because I see at least 10 students who are not doing it. Please wake up. You're gonna say, oh, it's a final test. It's just 11:45, right? So you have to do it so you can finish on time and go to the next class. 1 more minute and I will close the test. Good. Still 3 people are not doing it. Or probably 1 was absent. Chechi, check aquí. And Chang Hee Young, Pali, you have 15 seconds to do it. Okay. Most people finished it. So I think that's enough for today. Just enjoy spring, please, because the weather is nice and the flowers are beautiful. And see you tomorrow morning. Goodbye.